All right, I'm going to go over the Chapter 10 review. So let's get into it. So first part, we're going to talk about using the empirical rule. Um, I don't exactly have the empirical rule with me. Let me do a quick, let's see if I can draw one really quickly off the top of my head. So given that a distribution is normal, and say that this is the mean, this is one standard deviation left, and then this is two standard deviations left, and we have three standard deviations left, and same the other way, a standard deviation, two standard deviations, three standard deviations. Well, so given that we have this type of a distribution, say we split up the distribution by each standard deviation. Okay, so pretty much what it says, the empirical rule, is that inside this portion, within one standard deviation, you have 34% of your data, and then 34% on both left and right, so 68% total within the middle. If you go another step, that's going to be 13.5%. And then if you go another one, that's going to be 2.35%. So 2.35%. And on the very edges, you'll have 0.15%. 0.15%. I believe those are correct. Okay, so and these in this 1 through 4, you should be using this setup right here. So scores of 500 people on an IQ test are normally distributed and then there's a mean of 100, standard deviation of 15. So if you use the empirical rule set up for this one right here in dead center, we would have the 100. We'd have excuse me. We have 115, 130, and 145. We would have 85, and then we'd have 70, and then we'd have 55, if I'm doing my math right. So, okay, with that being said, it's going to follow this distribution over here. What is the probability of scoring between 85 and 130? So that would be between here and here. Well, just following the rule that we have up here, within one standard deviation is 34%. And then this would be, 34%. This would be 34%. And then this would be 13.5%. Okay, so that's everything in between. So what is the probability of scoring between 85% and 130? Or 85 and 130. So we're just going to add those up. So 34 and 34 is going to be 68. And then you add 13.5 to that. And you get 81.5. So 34% plus 34% plus 13.5% is going to be equal to 81.5%. I honestly don't care too much if you leave it as a percentage. I won't mark you wrong, but it is saying probability, and the probability would be 0.815. I'm okay with either answer. They mean the same to me, so. Okay, next one. What is the probability of scoring below 115? So I'm going to take this. I'm going to get rid of that. So scoring below 115. So I'm going to make a line at 115. And I'm going to add up everything below that. So again, since this was the mean right here, and then these are all a standard deviation. Okay, so if this was the mean, this would be 34%. This would be 13.5. This should be 2.35 and 0.15. So that's everything below 115. So let's go ahead and add it all up. So 34 and 34 is 68, plus 13.5, plus 2.35 plus 0.15, and I get 84%. So 84%, or you can say 0.84. Don't know why I did that one there. Yeah, 0.84. Either of those are good. Okay, how many? So notice that this is not a difference. We're not talking about probability or percentage. We're saying how many, and so it's saying how many of this 500. So we have to, not everybody of this 500 scored between 70 and 85. So obviously whatever number I give has to be lower than 500. So the only way I could put 500 is how many people scored between, I don't know, we could say between 55 and 145. We could say like upwards to 100%, maybe 99.9%, but yeah. So just know that you should, whenever you're answering these type of questions, when it says how many, you should never have an answer greater than the number that's given up there. So, and how we're going to do this? Well, all we need to do is find the probability and multiply the probability by the 500. Essentially what this is asking for. So let's say if we were to apply this type of question to one of these problems above. So let's say instead of saying what is the probability of scoring 85 to 130, what if we said how many scored between 85 and 130? What we would have done is taking this 0.815 and multiplied it by the 500, and that would tell me how many out of this 500 scored between them. So that's the same thing that we're going to do here. We're going to first find the probability between 70 and 85 and multiply that probability by the 500. Okay, so let's go ahead and keep what we have right here, because we're going to be adding up anyways. So okay, so it's between 70 and 85. So not those two values right there. Don't need those. Between 70 and not that one. Or just this one right here. So between 70 and 85, this is the only value that matters to us. So the probability between 70 and 85 would be 0.135. We're going to multiply that by the 500. So we do 500 times by 0.135, and we get 60. We'll round down to 67. It does give us 67.5, but we can't quite say 68 because we don't have a full number there. So 67 people out of this 500 will score between that. How many scored higher than 130? Okay, so using the distribution up here, let's find the probability first, and then we'll find how many. So the 130, so let me count this. We only want this area and this area right here. So that's the last two. So that would be 0.15, and this would be 2.35. Together, that's going to be 2.5. So I'm going to do, so that's 2.5%. Which means we would move the decimal place over 2 times. So 1, 2. And then we'd have 0.25, which is our probability. Multiply that by the 500. So 500 times by 0.025. And we get 12.5. So we'll round down to 12 people. So about 12 people will score more than 130. All right. For the next set of questions, we're going to be not using the empirical rule. We're going to be using the standard Z table, which pretty much just means that we can't use the empirical rule because our values are going to be set in between standard deviations, and so we have to convert it to Z-score to tell us how far in standard deviations a value is away from the curve. So an individual scores individual scores in a bowling league are normally distributed with a mean of 191.8 and a standard deviation of 3.8. Okay, so find the probability that a player bowls under 175. So just to maybe provide, it's still a normal distribution and whatnot. So we have a mean of 191.8 and a standard deviation of 13.8. So just for give you guys some idea of why we're doing this. So 191. Let me do the math here. 191.8 minus 13.8. So it's going to be 178 right there. And then we're going to subtract 13.8 again. And we're going to get 164.2. So 175 is somewhere in between here, maybe somewhere in here, but you can see that it's not exactly one standard deviation over. So to see how many standard deviations over, we're going to use the z-table. So first of all, we need to convert this to a z-score. So we're going to say z is equal to, this is where you take the x value, which is this right here. So 175, z is equal to x minus the standard deviation divided by the mean. Okay, so minus our standard deviation, sorry, I have these values mixed up. That's going to be the mean standard deviation. So 175 minus 191.8, and I'm going to divide that by 13.8. Okay, so punch that into my calculator, 175 minus 191.8, and divide that by 13.8, and that's going to give me a value of negative 1.217, but I'm going to round that up to the 2 decimal places, so negative 1.22. So this is my z-score. So I'm going to use this z-score at my table. Again, what I'm interested in is the probability that a player scores below. So I'm going to look at the area curve, and this is the area that I'm looking for. So go to the z-table, and on the negative z-score side, go to negative 1, so negative 1.22. So this right here is, so this would be negative 1.22 whenever I use this column, and this row right here, that's negative 1.22. And so that's going to give me 0.1112, and that number, that 0.1112, represents the area under the curve right here, or the percentage essentially. But in any case, this is the answer to what we need. The probability that it's under that score is 0.1112, or you could say 11.12%. I'm fine with either answer. Alright, for the next one, find the probability that a player bowls over 220. So 220, again, that's going to be a score somewhere over here, and what we're trying to find is the probability that they score over. So I need to find this area under the curve. So first of all, let me see the z-score that's going to represent this value. So I'm going to do 220 minus 191.8, divide that by 13.8. So 220 minus 191.8, 191.8, I'm going to divide that by 13.8, and I get 2.04. Okay, so then let's go ahead and look up the area for that. So z-table, it's positive, so go to the positive side. I'm going to go to 2.0 and then 4. So that's going to give me 0.9793. Now be careful. So that's going to give me 0.9793, but that number here is this area. It's the area to the left of that z-score. So it's all of this area, but we don't want that area. We want this area. So to do that, since the whole area is equal to 1 or 100%, we're going to do 1 minus 0.9793. So 1 minus 0.9793, and I'm going to get 0.0207, or I guess you could say 2.07%. Okay. Find the probability that a player bowls between 191 and 200. Okay, so this is an area of in between. So 191, 190 and 200. So 190, like somewhere like right here. 200 somewhere like right here. So what is the area in between those? So what we need to do is still the same thing. We need to find the z-scores for both of these values. So first let's start with 200. So z is equal to 200 minus 191.8 divided by 13.8. And so if I do that, that's going to give me 0.59. This is my z-score. Okay, now the area underneath the curve, let's go look at that. So to the left of that, so 0.059, so 0.059, so 0.7224, so 0.7224. Okay, next I'm going to do the same thing, but for the other score that I have. So I'm going to take the 190 minus 191.8 divided by 13.8. This is going to be really close to 0.5, I think anyways. So 190 minus 191.8, and then divide that by 13.8, and I get a z-score of negative 0.13. Okay, so let's look up the area for that one. Again, should be close to 0.5, so sorry, I forgot, negative 0.13, so negative 0.1, well, it's negative 0.1, so negative 0.1, there we go, negative 0.13, and then I get this area of, oh, whoops, that's on the positive side, yeah, okay, so negative 0.1, and then 3, there we go, so 0.4483, 0.4483. So these are the two areas that we have. The reason why I want both areas is because what I want to do, if you imagine it like this, so let me draw a quick sketch right here. Okay, so we have this z-score over here, and that's telling me, well, here's the area to the left of that z-score. So that's for, again, it kind of looks like it, right? So we have 72% of the area of the curves. That's what we got. Well, then we had another score right here. Now the area to the left of that was 0.44 right here. So 0.4483. So if I subtract these two areas together, what I'm going to be left with is the area in between them, which is what I want. This is the area of interest. So I need to subtract these two areas together. So I'm going to take 0.7224, I'm going to subtract 0.4483, and I'm going to get 0.2741, or you could say 27.41%. And there you go. So that's the probability that players bowl in between the 190 and 200 score. What score would a player have to get to be in the 90 percentile? So what this question is asking for a percentile rank, essentially. Okay, so 90% of the curve would be like this much right here, or 97 or 90% under the curve would probably be something right here. So what does the score have to be to score that? So let's look at our z-table and try and find a 90%. So we're looking inside here, not along here, because those are z-scores, and we're trying to find the z-score by using a percentage. So 90% of the curve is definitely going to be on the positive side, since that's the majority of it. So let's look for 90%. So that's 95%. Too large. Let's see. Let's go up a little bit. So 93%, 91. Oh, look right there. So we got 90. That's probably pretty close. I think this one's closer. So what is the z-score for that? That's 1.28. So 1.28 is the z-score. So z would have to be equal to 1.28. But again, I'm not looking for the z-score. I want the score. What score does the bowler have to get? So what is the z-score? What z-score will take this? How do I find the z-score? Or how do I find x value given a z-score? So we want to find the x value. We're going to use this same formula. We're just going to switch things around and solve for x instead of for z. So what we're going to do is we're going to say z is equal to the standard deviation multiplied by the z-score plus the mean. So if we do that, we'll get our score. So x is going to be equal to 13.8 times by our z-score, which is 1.28, and add the mean, which was 191.8. Right, yeah. Okay, so if I do that right there, that's going to give me 209. So you have to score 209 to get into the 90%, top 90%, which is a lot. Okay. All right. Let's keep going. So that was the first page. That one's probably the longest page, but okay. So the number of minutes per day spent talking on a cell phone by a sample of 412 students is normally distributed with a mean of 41.9 minutes and a standard deviation of 14.4. About how many students spend more than 60 minutes per day talking on their phone? So this is a question of how many. So not a probability, but we'll need probability to solve this one. Okay, so what we're looking for, the probability that they spend more than 60 minutes per day. So let's find a z-score for it, given that 60 minutes is going to be equal to 60 minus the mean, which is 41.9, divided by 14.4, which was the standard deviation. So we get 60 minus 41.9 divided by 14.4, and we get 1.2, we'll round that up, 1.26 right there. Okay, let's find the area. Now note that it does say more, okay, that's going to matter. So 1.2, we're almost there anyway, so 1.26, so that's 0.8962. So 0.8962 is the probability. I'm going to multiply the probability by the number of the people in the survey. So it's going to be, oh wait, no I'm not. I can't do that yet because this is the probability of them scoring, this is the probability of them spending less than. So for more than, I have to do 1 minus 0.8962. So then I do that, and I get 0.1038. So here's the probability of spending more than 60. Okay, I'm going to multiply that one by our sample, which was 412. And when I do that, I'm going to get, round it to 42 people. So about, or I guess 42 students, if we're being more specific, students. So about 42 students. Okay, what is the probability that a randomly selected student will spend more than 20 minutes per day talking on their cell phone? What probability? So this one's looking for a probability. I think that's all we really need. And spending less than. So all we need is area to the left in 20 minutes. So z-score, we'll do 20 minutes minus the mean, 41.9, divided by 14.4. So 20 minus 14.9 divided by 14.4, and we get sorry, one second, I typed something and wrong into my calculator. So 20 minutes minus 41.9, divide that by 14.4, and I got negative 1.52. Okay, and then find area to the left, so negative 1.52, negative 1.52. That's going to give me 0.0643. So 0.0643 is the probability of that. Okay. Probably just do these ones, and then we'll probably do a new video for other parts, because this is all just 10-1. So in the United States, the average weight of a newborn baby is 7.2 pounds with a standard deviation of 1.1 pounds. Determine what a baby would weigh to be considered in the 90 percentile. So this is a very same question almost as this. And since we already found that, the z-score associated with the 90 percentile, we're going to use that same one. So z is equal to 1.28. So for 90 percentile, z is equal to 1.28. and then I'm going to convert that to an x value, but using new values. So we're going to say x is equal to, we have to take the standard deviation, which is 1.1. We're going to multiply that by our z-score, which is 1.28. And then we are going to add the mean, 7.2. And when I do that, I get 8.6 pounds. So I determine what a baby would weigh to be considered in the 90th percentile, 8.6 pounds. Determine what a baby would weigh to be considered in the 15th percentile. Okay, so I'm going to look for an area that is 0.1500 or as close to that. So that's probably going to be on the negative side. So 0.15, not, so point. So this would be about 10%-ish. So got to go further than that. So here's 15%, but I think we can get better. 15, closer. So honestly, I think this one would be closer right there. So we'll take that score right there. So that's going to be the score of negative 1.04. So negative 1.04. Negative 1.04, do the same thing. X is going to be equal to the standard deviation multiplied by your z-score and add your mean. And then whenever we do that, we get 6.1 pounds. Okay, describe what it means for a baby to be in the 10th percentile. I guess what you could do for this one right here, you could actually find 10%, but it just basically just means that it's babies that are born with weights that would consider them to be bottom 10%. So you can say something to that effect. Okay, so I'm going to stop the video there. I'm going to pick up on 14 in the next one.